Good morning, students. My name is Dr. Arewa Ajibola. I'm here this morning to present a lecture on data and variables. I will start by defining what variables are. By definition, variables are characteristics that take different values at different times. Let me repeat. Variables are characteristics that take different values at different times. Even you as an individual, you can be called a variable because you take different values at different times. Conditions are variables because they take different values at different times. Variables are quite different from constants. Anything whose value does not change, it is called constant. Meaning that a variable is an opposite of a constant. A good example of a constant is the firmament. The firmament is constant. The village where you come from is constant because the position does not change over time. Where it was in 10 years, that is where it is today. Its value cannot change. But some other elements, conditions, property, individuals, whose values take different values at different times cannot be classified as constant, but rather they are classified as variables. This is the definition of a variable. And I'm too sure that by now you can define what a variable is. And even when you are asked what's a variable, simply say variables is an entity that has different values at different times. Time here could be hour, week, months, years, decade, and even century. Now let me tell you that there are different types of variables. There are different types of variables. Broadly speaking, we have two types. We have qualitative variables. Qualitative variables. And then we have quantitative variables. Quantitative variables, qualitative variables, is also called categorical variables. Categorical variables or discrete variables. So when we say discrete, categorical, or qualitative variables, is one side of the broad classification of variable. Then the other side is called continuous or quantitative variables. Now, this broad classification have other different types. Let me start from the qualitative or discrete or categorical variables. We have three types. We have the nominal, the dichotomous, and the ordinal variables. Yes, the nominal variables is a variable that can be categorized more than two groups, but it does not have an intrinsic order, or it doesn't follow an intrinsic order. But that is to say, when a variable is categorized into two or more forms, two or more categories, two or more classes, without following an intrinsic order, it is called a nominal variable. Let me cite an example. A very good example is an agent, a property agent, that classified property into different forms. For example, we have the bungalow, we have 3-bedroom flats, we have 2-bedroom flats. This is what we call, this category of variable is called a nominal variable, because it has more than two or more categories, two or more classes. Then even the classification of the system run in a country. For example, in Nigeria, we have the federal government, we have the state government, we have the local government. This system of classification is called a nominal variable. So when it is possible for you to classify a variable into two or more forms, two or more categories, they will refer to such variable as a nominal variable. Then the next one is dichotomous variable. A dichotomous variable is a variable that can only be classified into two forms, into two categories. A good example is gender. You can either have male or female, or war, period of war, or period without war, or crisis, period of crisis and period of no crisis, or pandemics or epidemics, period of epidemics and period where there was no epidemics. Period of epidemics will take 1, and period of where there's no epidemics will take 0. So this is what we call dichotomous variable. Variable that can be classified just only into two forms is referred to dichotomous variable. Then the other one is on this group, on the group of discrete variable. The other one is called ordinal variable. An ordinal variable is a variable that can be classified into two or more groups, but it has to follow an order. It must be ranked. It must be ranked. That is to say that it has a discrete, an intrinsic value. It follows an intrinsic order. For example, when you want to classify the policy of government, it could either be a harsh policy, a mid policy, or less than a mid policy, or less than a hard policy. So the category of this policy into different forms, or the categorization of this policy into different forms, actually called an ordinal variable. It follows an order, it follows a rank, but it is quite different from a nominal variable, where it doesn't follow a specific form. But in the case of ordinal, it follows a specific form, it follows a specific order. And that is why it is called an ordinal variable. Like the continuous variable. Continuous variable is a quantitative variable in nature. It has a numeric values. Let me say this. A very good distinction between an between a discrete variable, or between a discrete variable and then a continuous variable, is that a continuous variable is a numeric variable, while a discrete variable is a non-numeric variable. It has a qualitative characteristics, while a continuous variable has quantitative characteristics. Like I said, that there are different types of continuous variable or quantitative variables. 1. Interval variable. 2. Ratios variables. Interval variables. Interval variables are variables whose central characteristics can be observed within a continuum. Within a continuum. That is, it could be observed within a range. A very good example is the performance of students in a class. The performance of students in a class cannot exceed 100%. It has interval. It has a range. So any variable that has a limit in which it cannot exceed, in which its values cannot exceed. Remember I said a variable is a characteristics or an element that take different values. So when a variable takes a value that cannot exceed a particular limit, so such a variable is called interval variable. A ratio variable. Then a ratio variable is quite different from interval variable. Yet a ratio variable has strings that can take values to infinity. When we say ratio variable, we talk about variables that have decimal places, or variable that can be rounded off to decimal places. Let me tell you an example. The height of my very self may not be 6 feet exactly, or may not be 5 feet exactly. It could be 4.00009 feet. The mileage of a car, the distance of a road could be measured in 300.000999 kilometers. These are ratio variables, and they are called continuous variable. Now, I have succeeded in differentiating variable by the values and their qualities. We can also differentiate them by their positions in a model. As a researcher, you must have a model of interest for your investigation. So in your model, we have the right hand side variable and the left hand side variable. Yes, I just want you to picture out how a model looks like, an equilibrium model that has a sign of equal to the right hand side and the left hand side. The left hand side variable is called dependent variable, while the right hand side variables are called independent variables. Dependent variable can also be referred to response variable, explained variable, while the independent variable can also be referred to explanatory variable, predictors. They are called predictors. They can also be referred to included variables. Depends on which one you want to use for your study. But basically we call them dependent and independent variable. I will still say much on this when I get to model formulation after data. Here I've defined what data are, what variables are, types of variables. Then now, let me proceed further to give the definition of data. Data, to a literal man, is referred to piece of information. Piece of information. So any information you have about a variable is called data. Now, let me say this again. The value of a variable or the value collected on a variable is what we refer to data. The value collected on a variable is what we refer to data. Like I said, my very self is a variable. Then when you collect data on my height, assuming you take my height and it is 3 feet per 99 centimeter, or feet rather, then that 3.99 feet is a data collected on my height. My height is the variable. So with this, you should be able to differentiate between a variable and a data. Data is information gathered on a variable. Variable is the one that takes the value of the data. Now, let's classify data. I want to tell you that datum is the singular form of data. Data X plural. However, it can take the verb X. Data can take the verb X and it can also take the verb are. Depends on the one you want to use. The data is not enough. The data are not enough. You are correct, whichever one you use. So I will classify data by sources. Then I will also classify data by time. Time. Yes, by sources. When data are collected from a published source, we call such data secondary data. All published data are called secondary data. A good example is exchange rate of a country, GDP of a country. They are published data. Unpublished data are primary data. When data are manufactured, let me use the word manufactured on quote. When data are manufactured by a researcher himself or herself, such data is called primary data. Usually, primary data could be collected through questionnaires or interview. Once you go to the field and you interview people to gather information from them, such data is referred to primary data. Or otherwise, when you structure questionnaires and administer them to get information from them, such data is called primary data also. What is most important here is that the source of the data. If the source is from a published source, then you refer to it secondary data. However, if it is from you, the researcher, you refer to it as secondary data. Then we can also quantify data by time. By time. When data are classified by time, then we can have three types. First, we have the time series data. Then, secondly, we have the cross-sectional data. Then we also have the panel data. I'm sure that this might be very new to you, or rather, you are hearing this for the first time. But let's look at the meaning of time series data. As the name implies, You can simply define time series data as data collected on a variable or set of variables over time. Over time. So when data are collected on a variable or group of variables over time, we call such data time series data. Time here specifically could mean hour, days, week, annum, biannum, decades, and even century. This implies that you can collect data over years. You can also collect data over days, over weeks, on hourly basis. If it is collected on hourly basis, it's this time series. Even over century, it's this time series. But what is important is that it must cut across time. So the time is the frequency of occurrence of the data. The frequency of occurrence of the data is the time. If the data occurred frequently, then we call them higher frequency data. If it does not occur frequently, like yearly data, data on decade basis or century basis, they are low frequency data. I must point out here, because so many students make unpardonable mistakes. I call it unpardonable mistake because it is a deadly sin that can even be committed by experts in statistics. When you are collecting your data, what is important is the data points, not the frequency of observation that matters. So your data point for a time series observation should not be less than 30 observation. Should not be less than 30 observation. If your observation is less than 30, then your analysis may be discredited in one way or the other. Even some experts in statistics commit this deadly sin of running analysis with observations that is actually less than 30. So when you are dealing with time series analysis, the minimum observations you could have is 30, whether on low frequency data or medium frequency data or high frequency data. It doesn't matter whether the data is on yearly basis, on century basis, or on daily basis. What matters is the numbers of observation. Meaning that you can run analysis with daily data if the data, you can run analysis with daily data for a year. If you have observation that is more than 30. Because that wouldn't discredit your regression result, or rather its spurious. So the asymptotic nature of your analysis depends on observation, not on the frequency of the data. Please take it very importantly. Cross-sectional data. Cross-sectional data are also data collected on a variable or set of variables at a point in time, at a time, and across units. At a time could be just 1 year, 1 month, 1 day, 1 hour. Not 2 years, not 3 years. It must not cut across time, just at a point in time, but it will cross across units. it must cross across units. Units here could be individuals, companies, countries, set of religion, local governments, villages, but it must just be a unit. Let me cite an example. When you collect data on profit, or you collect data on return on asset for more than 10 companies, or for more than even 2 companies, but for 1 year or for 1 month, such data is called cross-sectional data because they actually cut across units, not across time. Please put on the generator. So the most important thing is whether the data cut across units or they cut across time. When they cut across units, they will call them cross-sectional. The dimension is across unit. But when the dimension is across time, it is called the time series. So this is the simplest way by which you can differentiate between a time series data and then cross-sectional data. Now we have the panel data or longitudinal data. A longitudinal data are data that are collected on variables or on a variable across units and over time. When you collect a data across unit and across time, such data is called longitudinal or panel data. The reason why we call it panel or pool data is that it has the characteristics of both cross-sectional and time series. For the fact that it cuts across time and it also crosses across units, we refer to it as panel data. And I must say that there are different types of panel data also. We have micro panel data, then we have macro panel data. The micro panel data, that is, I mean M-I-C-R-O, micro, is the one that the time dimension is smaller than the unit dimension. While the macro, I mean M-A-C-R-O, is the one that the time dimension is larger than the unit dimension. So let me give an example of panel data. When data is collected on exchange rate for Nigeria, Ghana, South Africa, Egypt, Lesotho, for 10 years, such data is called panel because it cuts across countries and it also cuts across years. How is it different from time series? In the case of time series, it only crosses across time. So when you collect data on exchange rate for Nigeria alone and for 10 years, then you refer to it as time series data. And I must tell you that in modeling relationship, it depends on the data you have at hand. Then the technique that will be used also depends on your response variable. I've told you what response variable is. Response variable is your dependent variable. I will say something here that is very, very unique. When your response variable follow a normal distribution, when your response variable follows a normal distribution, then you can apply ordinary least square method for your analysis. What is is a normal distribution? A normal distribution is a distribution that is Gaussian with zero mean and constant variance. At least approximately zero and approximately constant. So we can have an approximate normal distribution process. So when the response variable follow a normal distribution process, a Gaussian process, that is only where you can use OLX as a means of analyzing, as a means of evaluating, and as a means of calculating the parameter of your model. Yes, for example, you have GDP as your dependent variable. GDP is a variable that follows a normal distribution. Then you can use OLX. Exchange rate, for example, profits, for example, even return on asset, for example, you can use OLX for your estimation techniques. But there are some exceptional cases where you cannot use OLX. When your response variable follow a binomial distribution or a Poisson distribution, you can't use OLX. And this is a mistake so many students have been making. So you must know the distribution of your response variable before you can now adopt any method for your analysis. For example, let me talk of a binary variable. Crisis. Crisis is a dummy variable. And if a dummy variable is your dependent variable, that is, it takes value between 0 and 1, then you cannot use OLX for estimation techniques. It's either you use Probit's estimation techniques. Then, if your response variable takes value within a continuum, then you'll be talking about logic. It's a logic regression analysis. You can't use OLX regression analysis. So always take notes of your response variable. Take note of your response variable. Also take note of the numbers of your observation before choosing the techniques of your analysis. Now I have defined what variables are. I've also defined what data are. I think the next thing is to explain to you how to start your investigation in the research work. First, you need to have a topic. You frame the topic. Let me give an example. Impact of microeconomic variables on stock market development. This is just a good example of a topic. And as good as it is, your model must capture your topic. In most studies, particularly here in Nigeria, the model in some cases is different from the topic. That is a misdemeanor, a misleading concept. Your topic and your model and your objective of study must be aligned. So the case of microeconomic variables and stock market development, how are you going to frame your model? Which one is going to be your dependent variable and which ones will be your independent variable? In this case, you are looking at the impact of microeconomic variables on market development. It means that microeconomic variables will be your independent variable because you examine their impact on the dependent variable. So you examine the impact of independent variable on the dependent variables. So in this case, the independent variables are the microeconomic variables, while the dependent variable is the market development, which can be represented by capitalization or market index. And the macroeconomic variables, a good example is exchange rate, inflation, interest rate. These are good examples of microeconomic variables. So the choice of your model, the choice of your variable must depend on the topic at hand. Now, I still discover that students do not know how to collect data. Most of the time, they find it difficult collecting data, and they fabricate data. The simple ways to collect data that may not cost you much headache is to use the avenue of internet. Now, I will just give an example, and I will use my laptop. I hope I'm connected. I will use my laptop on how to collect data using internet. Just make sure that you are on Google. Oh, limited service. This is funny. Limited service. So, I am having a limited service. I'm trying to see if the service can improve, and I hope that will be done within the shortest possible time. Before then, I would like to reverse back to model formulation. I would like to reverse back to model formulation. When you formulate your model, before you estimate the model, first of all, you need to describe your variables. Because in analysis, there are two types of important aspects of analysis. We have the descriptive, we have the inferential. In studies in finance and other related courses, this is very essential. The descriptive is used to describe the data. It could be visual, it could be statistics. You use that to describe the data. And when you have described the data, then you can now conduct an inferential statistics. The inferential statistics actually estimate the relationship and produce results on the cause and effect analysis. Well, it seems that I'm still having a limited service, but however, let me just tell you what you will do. You just go to Google, then click on it, type the data you want to collect, the variable you want to collect data on. For example, let's say it's exchange rate. Type exchange rate data, then type World Bank and enter. It will take you straight to the website of World Bank and where exchange rate data are. Not only that, the one that correspond to the countries you want to collect the data on. And if it's just time series and want to collect data on Nigeria, you just pick the one for Nigeria. Then thereafter, you can now extract the data and the numbers of years you want for your own analysis. I will continue from here by the grace of God next week. Next week, we'll be having fresh topic. And I want you to read ahead. Next week, I'll be taking on sample and population of the study. Please, I want you to do much work on sample size, sample techniques, and population of the study before this time next year. And God bless you. I mean next week, not next year, next week. And God bless you and remain blessed. Thank you so much.